Hi everybody, this is Dr. Hamid with your College Mathematics 120 class. Today we'll talk about integers and order of operations, and this is section 5.2. In today's lecture, we will extend the concept of natural numbers to integers. Okay, we talked about natural numbers and related things in section 5.1. So in this section, we will define integers and how to graph them on a real number line. We will introduce and learn how to use bigger than and smaller than concepts. Okay, and we will also talk about the absolute value of the integer, some basic operations with integers, and how to deal with the order of operation if we have different operations, addition, multiplication, subtraction, and all that, how to deal with them, which one to perform first, which one to perform later. Okay, so order of operations. Let's start with integers. Remember in section 5.1 we talked about natural numbers. Natural numbers are counting numbers which we use to count things. So they start at 1, 2, 3, 4, so on, so on, so on, all the way to infinity. Okay. Now if we add 0 to natural numbers, okay, we also include 0, which means nothing. Okay, then we get whole numbers. Okay, so this is another category. So if we add 0 to natural numbers, we get whole numbers. And now to whole numbers, if we also include negatives, okay, so -1, -2, -3, all the way to infinity, minus infinity, and this way 1, 2, 3, all the way to infinity, these are called integers. Okay, so if we extend whole numbers to include negatives, we get integers. Okay, so integers are whole numbers that that can also describe natural numbers in an opposite way. Opposite way means minus sign with it. Okay, so integers, natural numbers are strictly positive starting at 1. Whole numbers have 0 in it, and the integers can be negative, positive, or 0. Okay, as long as they are the whole thing. Okay, whole number. The 0 integer is neutral. It's neither positive nor negative. We all know that, but still it's an integer. Okay. Now integers, we can represent integers on a number line, which can help us understand the value of the integer. Okay, which will, we will relate it to what is bigger, what is smaller, and so on. Okay. So let's talk about positive and negative and positive integers. The term positive integer is another name for natural numbers. Okay, if we don't talk about 0 there, we can represent positive integers in two ways. Either we can put a positive sign in front of it. Okay, for example, positive 4 is an integer. Okay, it's a positive, it's a 4 uh, with a plus sign in front of it, or we do not need to write the plus sign explicitly. Okay, so if we do, even if we don't have a sign, it means positive. If we have to have represent a negative number, then we have to put a negative sign in front. Okay, negative integers are obtained by negating positive integers. By negating means putting a negative sign in front of it. Okay, so they are represented by putting a minus sign in front of the number. For example, -4 minus 4 is read as -4 there. So how will we write integers then? Integers are, it will have 0 in the middle, positive on the right, negative on the left. Okay, that gives rise to a real number line. Okay, or number line. So this number line, these arrows means that this line extends all the way to positive infinity to this side. Okay, and minus 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 all the way to minus infinity, highest number on the left there. Okay, in the middle we have 0. So this number line, we use it, it is used to visualize the set of integers. Okay, as well as set of other numbers. So again, 0 is not a positive, not a negative. This thing here is called a number line. You will see that it will be very helpful here. Any number, number to the right are bigger in value. Number to the left are smaller in value. Okay, if it is at 0, then it has no value in there. Now, before I get into the further details of you know of integers and operations and all that. Let me talk about, I would like to give few examples from our daily life, okay, where integers are used to express physical situations. For example, okay, this is a reading of a thermometer. Okay, the readings on a thermometer are given in integers. Okay, you see some positive numbers, you see some negative numbers here. Okay, now in this particular example, the thermometer shows 10 degrees Fahrenheit, which is an integer. Okay, so it's a positive whole number, it's an integer. Okay, now similarly, if we are in snow season, then we might have a negative number here. Okay, in this one here, our thermometer shows minus 10 degrees Celsius this time, Fahrenheit. Okay, so what it tells us that the temperature is minus 10, so it can be positive, it can be minus. So these, the reason for this slide is, these negative numbers come into play. Okay, negative whole numbers, negative integers. Okay, they come into play in our daily life. We see them all around us. Okay. One other example is, we describe things, above sea level or below sea level. Okay, so positive integers, they indicate height above sea level. For example, aeroplane flying, or a city is located above sea level or below sea level. Okay, so an aeroplane is 80 meters above sea level. So this is sea level here. Anything below will be represented by negative integers. Anything above sea level is represented by positive integers. Okay, so there's another example where we see them around us. I think it's enough. Let's move on to how to graph or put these numbers on a number line. Remember that number line which has two arrows on both sides, and a zero in the middle, positives on the right, negatives on the left. Okay, so we have to let's practice by graphing these integers on a number line. Suppose we want to graph minus 3, 4 and 0 on a number line. Okay, to graph these numbers, we will draw a line from minus infinity to infinity. Okay, and place a big dot at the correct location of each integer. Okay, so this is a line. These arrows, remember, these arrows means that they go all the way to infinity. You can, symbolically speaking, you can put infinity there, you can put infinity there. Now let's look at minus 3 here. Where is minus 3? This should be to the left of 0, so this is minus 3. We put a dot there, that's it. Okay, where is 4? 4 is to the right of 0, which is right there. Okay, and where is 0? 0 is in the middle. So that's how you will graph numbers on integers on a number line. Next thing is how to compare integers. Okay, now some integers have small value, some integers have bigger value. Okay, so then we can say that, for example, 100 is bigger than 2. Okay, or 2 is less than 100. Okay, so that comparative value, comparative relationship between integers, we're going to talk about that. Now, real number line can also be used to compare and decide which integer is bigger or smaller. Okay, remember that on a number line, when something is to the right, okay, that means it's bigger. When something is to the left, that means smaller. Now if we compare 2 and 3, if we put it on a real number line, 2 is on the left of 3, and 3 is on the right of 2, so that means 3 is bigger than 2. Okay, or 2 is less than 3. So if you want to represent 3 is bigger than 2, you will use this symbol here. I'm going to talk about it in for more detail here. So this symbol means it always points, this edge here, it points to the smaller number always. Okay, so this means that 3 is bigger than 2. Similarly, suppose we want to compare minus 3 and minus 5. Okay, might be a tricky one, but again we will put them on a real number line. Okay, the number on the left will be smaller, so minus 5 is smaller than minus 3. So you can think of it as, if you owe somebody $5 and other one owes $3. Okay, so 5 is a more loan you owe. Okay, so minus 3 is bigger than minus 5. And as I said earlier, this point, this symbol points towards the smaller one. Okay, now let's talk a little bit more about these symbols here. These symbols are called inequality symbols. Okay, this one is inequality symbols. These symbols always point to the lesser of the two of the real numbers of the numbers. Okay, when an inequality statement is true, if whatever we are talking about makes sense, then it will always, this thing points towards the smaller one. Okay, so for example here, if we are comparing -4 and -1, -4 is less than 1, so this one is pointing toward the less one here. Okay, we can also say the same thing the other way around, that -1 is bigger than -4, so where again it's pointing towards the smaller one here, and it opens towards the bigger one. There are some problems like this one on your homeworks and quiz. So let's practice few numbers here. For how the symbol will go here, it will be this way or this way. Okay, 4 is, oh, why I have -4? I don't know. Let me correct it. Okay, so 4 is, it should be the other way around now. Okay, 4 is bigger than 3. Okay, and now what about -1 and -5? So -1 is bigger than -5. Okay, or -5 is smaller. How about this, -5 and -2? Okay, -2 is bigger, -5 is smaller, so it will be like this one here. Okay, like this. And similarly, how about 0 and -3? So 0 is bigger, so it will be like this, it will open towards the bigger one, so like that one here. Okay, just for your practice here, sorry about this mix up. Okay, now we can also have these symbols. Okay, we can also have this bigger than or smaller symbols with equation, with equality. Okay, so how we will do, we'll just put a line below it. Okay, the symbols, this one and this one, may also be combined with an equal sign by putting a line below it. For example, like this one here. Okay, you see that A is less than B, but if you have line below it, it means A is less than or equal to B. Okay, so we are introducing equality as well. Okay, for example, 2 is less than or equal less than or equal to 9. Okay, so it means two things here. It means that 2 is less than 9 and 2 is equal to 9 as well. Okay, because of this one here. Okay, now similarly we can have the other way around, this symbol, and with a line below it, it will mean B is greater than or equal to A. Okay, so we will have, if we deal with this kind of thing here, we have to consider both equality and inequality. Okay, equation and inequality, both. Okay, let's move on to a very important concept. I'm sure you have seen this before. This is called absolute value. Okay, the absolute value of any integer. Okay, let's say A, we denote it by A and 2 bars on sides. Okay, so it's called absolute value of A. This is called absolute value of A. Okay, and it is basically the distance from the origin O to the point A, wherever the point A is on the real number line. Okay, now since the absolute value, by definition, it represents a distance. Okay, so it cannot be negative. Whatever goes in here, it will come out as a positive number. Okay, so you can think of it as if -3. Okay, absolute value of -3 is just 3. Absolute value of 3 is also 3. Absolute value of 5 is 5. Okay, what it tells us, that -3, absolute of -3 is that it's the distance, how many units from the origin. Since it's 3 units, so that's what the answer is. Okay, absolute value of 0 is also 0 there. Now let's talk about how to add integers. So if the integers have same signs, okay, we will add their absolute values, and sign of the result of the sum will be the sign of the two numbers. Okay, same as the two numbers, since they have the same sign, so any sign you can pick. As an example, you can look at this one here. If you want to add minus 11 to minus 15, okay, you will ignore all the signs, okay, or take the absolute value of minus 11, which is 11, minus 15, which is 15. Okay, add 11 and 15, which will be 26. Okay, now what will be the sign? Sign will be, since they have same signs, so you can pick that sign. We'll go with that one here. Okay. Now if the integers have different signs, what happens then? Then we want to do is, if they have different signs, we will subtract the smaller absolute value, okay, from the larger absolute value. Again, we will take the absolute value of each integer and subtract the smaller absolute value from the larger absolute value. Okay, for example, look at this one here. Suppose we want to, we have different signs here. One integer is minus 13, other one is 4. Okay, they have different signs. So just subtract this one here. Absolute value of 4 is 4. Absolute value of 13 is 13. Subtract them and it will give us 9. Don't worry about the signs. Now how about the signs? The sign of the sum will be same as the sign of the number with the larger absolute value. So if you have 13 and 4, okay, so the sign will be the of a bigger number. Okay, here we have minus 13 and 4, so sign will be minus, because sign minus the sign of the 13 there. Okay, similarly you can have 13 and minus 6. This time sign will be of a bigger, so which is positive. That's why we have positive there. Okay, that's we have. How will we add integers? Additive inverse is something which makes the result 0 basically. Okay, so when we add additive inverse, the sum will be equal to 0. That kind of thing is called additive inverse. For example, 18, okay, its additive inverse is minus 18, because when we add to it, it will give us 0. Okay, so in general you can have a, its additive inverse will be minus a. Okay, that will make it 0. So anything which has the same absolute value but opposite sign is called additive inverse. Okay, now we will use the concept of additive inverse into subtraction of integers. So how to subtract integers? Suppose we have two integers a and b. Okay, to subtract them, we basically we will be adding. Okay, so we'll be adding a plus minus b. Okay, so to subtract b from a, add the additive inverse of b to a. Okay, so the result of subtraction is also called difference of two integers. You already know that. Let's talk about some examples and rules there. So if you want to subtract integers, suppose you want to subtract 17. Okay, from 17 we want to subtract minus 11. 17 minus 11. So we'll distribute this negative. Okay, minus times minus is plus, and then we'll just add these numbers. Okay, let's look at another example here. Suppose we want to have subtract minus 18 from minus 5. So now minus minus will become plus again here. Change the subtraction to addition. So it will give us 80 minus 18 plus 5, which is you combine the two, it will give you minus 13 there. One more example. Suppose you want to have minus 18 minus 5, both are negative. Okay, so just you're adding, okay, basically the absolute value of the two, and then putting the sign of the bigger of any of the ones too. Okay, so it will be minus 23 and negative sign in front of them. Okay, next one is multiplication of integers. Okay, how to multiply two integers? It's called the product of numbers as well. You can think of multiplication as a repeated addition, okay, or subtraction that starts at 0. For example, 3 multiplied by 8 is basically the same thing as we are adding 8 3 times to 0. So 0 plus 8 plus 8 plus 8, that will be 24. So that's what the product is by definition. Okay, so there are some rules involving products as well. the product of two integers with different signs, okay, is found by multiplying their absolute values, and since it's a different sign, the final product will be negative. Example, if you multiply 7 times minus 5, so you multiply these two, okay, 35, and then put the negative in front. Okay, different signs, minus. If you have same signs, you will multiply like that one, but the final product will be a plus product. So the product of two integers with the same signs is found by multiplying their absolute values, okay, and the final product will be positive there this time. Since we have, you know, same signs, minus times minus will be plus, and then 11 times 6 will be 66. That's it. Okay, look at one more sort of a funny one. The product of 0 with any number, any integer, 0 will make the whole thing 0. Okay, so 0 times 17 is 0, 0 times 100 is 0, whatever it is 0. Okay, continued. Now if no number is 0, okay, we are not, numbers we are dealing with is other than 0, then the product with an odd number of negatives, okay, if you have 3 products or 5 products, okay, then the final product will always be negative. Okay, so see, you have 3 products there, all minuses, so minus times minus plus, then plus times minus is minus. Okay, so it will be minus. If you have even number of products, okay, even number of negatives, okay, then the final product will be positive. Look at that. Okay, so this time we have you know, we have minus 2 times 3, which will be minus 6. Minus 6 times minus 5 will be plus 30. So a product with an even number of negatives, it will turn out to be positive there, because, you know, minus times minus is plus, and again minus, it will go back to minus. Keep that in mind. Now you know, how multiplications and exponential notation are related. Exponents, actually, we talked about it, it indicate repeated multiplication. Okay, so if you have 8 to the power 2, it means 8 times 8. If you have 8 to the power 4, it means 8 times 8 times 8 times 8. Okay, so we can use the same, you know, rules for multiplication to evaluate exponential expressions. For example, if you want to evaluate minus 6 to the power 2, what does it mean? It basically means that minus 6, okay, times minus 6. And then, so what is minus times minus? It is plus. 6 times 6 is 36. It will be 36. Okay, so we can use the same rules of multiplication for exponentials as well. Let's look at another one. This time again we have minus 6 squared. Okay, so minus is not squared. In this one, minus was squared. Here minus is not squared. So we have minus 6 squared, means that minus aside, and then 6 times 6, this time it will be minus 36. Okay, similarly, minus 2 to the power 4 will be 4 times it with itself. So 4 minuses, even minuses, will give us plus. Okay, 2 times 2 times 2 times 2 is 16. Okay, let's talk about the division of integers. The result of dividing integer a by a non-zero integer b is called exponent. Is called quotient of a number. Okay, division is also called quotient. So do we represent division a divided by b as a with this, you know, sort of a diagonal bar b. Okay, I guess as an example you can think of it this one. If you have minus 12 divided by 4, it is minus 12 divided by 4, and you can, you know, if you divide it, you will get minus 3 there. Okay, now just to check your work, if you multiply, you know, these two, you should get what you divided originally. Okay, you should get minus 12, and we do get minus 12 there. Let's talk about rules of division. Okay, the first rule is, if you are dividing two integers with different signs, okay, is found by dividing their absolute values, and the final answer will be negative. Okay, so if you're dividing 80 by minus 4, the final answer will be negative here. Okay, similarly, if you are dividing, you know, two integers with the same signs, okay, then the final answer will be positive. This is the minuses and pluses, that's where you get confused the most, okay. So if you have 27 divided by 9, 27 is positive, 9 is positive, so no need to worry, the final answer will be the positive 3, okay. Similarly, if you're dividing by minus 45 divided by minus 3, the final answer will be 15, no need to worry, okay. Now you cannot divide anything by 0, okay. So 0 divided by any non-zero number will be 0, okay, and division by 0 is undefined. If you have 0 in the numerator, it's okay, okay. You cannot have 0 in the denominator, things break down, okay. Let's talk about the final thing, the order of operations. You know, sometimes we have bunch of operations, so perform all the operations with the grouping symbols first, okay. If there are any parentheses, brackets, some things are enclosed, you want to do that first, okay. So and then evaluate all exponential expressions, anything in the exponential, okay. Then do all the multiplications and divisions in order they occur, okay, and always work from left to right. And finally, at the end, you want to do additions and subtractions, and again in the order they occur, and you always start from left to right. That this is the slide you want to remember, how to deal with the order of operations. First of all, parentheses, then exponentials, then multiplications and divisions, then additions and subtractions, and always work from left to right, okay. Let's look at this one example here. So we have some exponentials here, 6 to the power 2 minus 24 divided by 2 to the power 2 times 3 plus 1. So how will we do here? There are no grouping, okay, so we do not have any parentheses there, so no grouping. So we begin by exponentials here, so we want to work out this one and this one first, okay. So let's do that. So this will give us 36, this will give us 4, and we did not do anything other than that. Now what comes next? Next is division and multiplication, okay. So divide this by this one, so what we have, 6 here, okay, and next is multiplication. So it's not addition, it's multiplication. Multiplication, okay. So next is multiplication. So we multiplied 3 times 6, which gives us 18, and next is addition and subtraction, so we can combine all this, okay, and gives us 18 plus 1, so 19, okay. So exponentials, division, multiplication, okay, and then addition and subtraction at the end. But that's it for this lecture. It's sort of an easy lecture, okay. I'm sure you have seen these concepts before, but still I want you to practice. I want you to excuse me. Please try the homework problems assigned in my math lab. Do the quiz. If you need any help, contact me. Thank you very much. Bye bye.